All right, let's look at the homework 4.2, problem number 2. All right, so we have this function 9 minus x to the 2/3 power. We want to find f of negative 27 and f of 27. All right, so let's do that. So f of negative 27 would be, right, so you have a 9, right, minus. Right, so we're going to break it into, this is a cube root and a square. So I'm going to take negative 27 and take the cube root first because it's easier to do. And then square that. Right, so what's this? So 9 is 9 minus. Right, so cube root of negative 27 is negative 3. And I'm going to square that. So this is going to be simply 9 minus 9, so this is going to be 0. Right? How about f of 27? Right, so we can just do the same thing. 9 minus, take the cube root of this time positive 27 and raise that to the second power. So it's going to be 9 minus, cube root of 27 is positive 3, and you're going to square that. Then again, 9 minus 3 squared is 9, and it's also 0. So answer is both 0 here. We got 0 for f of negative 7 and 0 there. All right. Alright, and then it says that for all values c in between negative 7 and a positive 7 such that the f prime of c equal to 0. Alright, so let's find the derivative first. Alright, so f prime of x is equal to derivative of 9 is 0, and then derivative of negative x to the 2/3 power would be negative. Put the 2/3 in front, x to the, subtract 1 from the power, so it's negative 1/3. So if you rewrite it, this is going to be negative, and 2 is on top, and on the bottom you have 3 cube root of x. Alright, but unfortunately, for any x, this derivative is actually never 0. So which means that such c does not exist. So d does not exist. Alright, so this is a problem, right? Because Rolle's theorem actually tells us that there's going to be at least one c. Right? The problem is, if you look at the derivative here, right? So this derivative is not defined here. So f prime of 0 is not defined. Alright, so which means that f is not differentiable at 0. Right, so it does not satisfy one of the hypotheses of the Rolle's theorem. So Rolle's theorem just simply doesn't apply here. All right, so see, this contradicts. It does not contradict. Since no, this contradicts. Does not contradict Rolle's theorem. Since f prime of 0 does not exist, it's not differentiable. So here, so this is the reason. All right, let's check the answer. Alright, I came back and looks like we got all of the parts correctly. Alright, that's it. I hope that this was clear.